Some of the things that we have to consider when we're using this equipment is swing fall, and time again I see particularly in construction that end users have way too much swing fall, where they're walking too far away from the anchorage point with a self-retracting lifeline. They fall and then they could swing into an abutment or even hit the ground. You can see obviously from the picture on the right that somebody was measuring their clearance distance from the ground and not the nearest obstruction. So another thing to keep in mind. Oftentimes you'll hear with SRLs that you need to keep the angle less than or equal to 30 degrees, and we shy away from using 30 degrees. First of all, it's hard to measure, and second of all, in Minnesota, when you say 30 degrees, people think that, oh, I don't have to work until winter. So we look at the chart here, and that gives us the proper amount of distance. Plus, the higher the retractable is above your head, the greater the leg or hypotenuse of that triangle gets, and potentially could create more swing fall. Some of our basics with using a fall arrest system is a body support, connectors, anchorage connectors, and a rescue plan. Starting with our body support, pretty important to have that harness adjusted properly on your body. The injuries it can cause with loose leg straps are pretty horrendous. Body belts, as you may or may not know, can no longer be used for fall arrest. They cause injuries and they're illegal, but they do still have a place in the fall protection industry. You can see in the photo on the left, the individual is using it for what we call work positioning. How many times have you seen somebody trying to do a job and they're reaching way out as they're trying to work? And with work positioning, it allows people to work with two hands and be held on to the anchorage point, and makes the work much more safer and efficient. And of course, in the lower right, you can see these using a form of restraint. There's different harnesses for different uses. If people need to ascend and descend, there's different designs. There's literally hundreds of different designs in harnesses, and also of materials as well. Some people complain that some of their harnesses wear out too quickly because welders keep putting holes in them. So if that's the case, look at getting maybe a Kevlar Nomex harness. There's all we do is fall protection, so there's a pretty good chance we're going to have some sort of a solution for some of those problems of harnesses wearing out a little quickly. Let's talk a little bit about some of the harness safety points. We always remind people to have that harness 100% on or 100% off. Why? Because we find that when people take off the leg straps, that's usually the first thing they take off, that they sometimes forget to put them back on. And also, if you're working around moving machinery and have loose straps, they can get caught in the machinery and pull it in. Now, the straps are rated at 5,000 pounds. That's a battle you're not going to win. Some of the things that we look at, what could happen if we hook up to the improper D-ring. We're going to take a look at a video clip, and we'll see some dummies that are dropped when they're hooked up to different areas of their harness. And harness is loose, can cause severe injuries, particularly if you're a male. And if you're suspended for over 30 minutes, there's some issues there that we're gonna mention briefly here. What I've got here is a clip with some mannequins being dropped. It takes just a moment to queue up. We're going to see one dropped with wearing a body belt. Now the mannequin is hooked up to a rope with no energy absorber, so he's feeling probably about 2,400 to 2,600 pounds. You can see that belt's cinched up very tight around the waist of the mannequin. Next one is hooked up to the back D-ring. Again, no energy absorber, and the mannequin flops around a little bit in this one. The one that's coming up is probably one of the most interesting ones, as you're going to see what happens if you're hooked up to the front D-ring. Practice is very dangerous. You can see flipped over. The next one we're going to see is a mannequin hooked up on a different style harness. It's called a sit harness. Some of you may have seen those on rock climbing walls, and the attachment point's actually lower, so the neck snap is really exaggerated in this one. So I'm just trying to give out a few points here that we can recognize easily when we're out there for using this equipment. Make sure that harness is on snugly. Hooking up to the front D-ring in a fall arrest situation is very dangerous. We're going to compare that to now with a full body harness with the energy absorber hooked up correctly to the back. And notice that horizontal bar where it is on the mannequin, because the next one's a self-retracting lifeline. We're going to see the stopping distance is reduced by quite a bit here. Okay, what do we have here? Biggest guy in the crew happened to be the one who fell. Does he look comfortable? He doesn't look real comfortable. He's not adjusting his necktie. He's wearing a loose harness. So another point is that harness is going to ride up on an individual who's not wearing it properly. We need to make sure it's snug. There is another hazard, though. With your suspended workers, you need to have a rescue plan that will allow you to get them down. The window we usually recommend is about 6 to 15 minutes to get that person down. And that's actually a responsibility of the employer to provide prompt rescue of a fall victim. Calling the fire department out can be a good secondary plan, but unless you have a written contract from your fire department guaranteeing a prompt rescue, that's not going to work. Mentioned that being suspended for too long can cause some serious problems. It's called suspension trauma. Some of the symptoms are going to be you feel nauseous, you may feel numbness or tingling in your legs or arms. What it is pooling of blood in the legs, and the legs actually work as a pump to help circulate the blood. And when you're suspended, that blood doesn't circulate. Some of you may have seen somebody pass out in a wedding or while they're standing at attention in a parade. That's a form of orthostatic intolerance. The blood isn't flowing around well in the body because their knees are what? Knees are locked. I wanted to mention a couple important points about connectors. There's been some changes in the industry where the gate strength has been increased. We found that there's been some problems that if the connection is incompatible, that the gates would burst open. We're going to see a video clip of this here. Oh, here's actually an example. This was on a wind turbine, 267 feet in the air on a training that I did in Colorado. And if you look at that large part of the snap hook right here, you can see it was blown open. An electrician was working on top of the wind turbine when he was connected at his feet. So if it's below the shoulder, he had way too much free fall, and the connection was incompatible. A very small lift eye with a large snap hook put into it. When he fell, it failed, but it was his lucky day because he was caught between the hub and the nacelle at the top of that wind turbine, and they rescued him. He returned to work the next day, but I couldn't find a better example of an incompatible connection and what could be the result of it. So because of this, we've come up with stronger snap hooks and carabiners, the connecting means. How can you tell if you've got the reinforced gate? It simply says gate strength on the side, and it'll say 3,600. If you do not see the word gate strength on the part that opens on the carabiner or snap hook, then you have the old style, which is 300-pound gate. You do not have to get rid of your old snap hooks, but be aware of it and make sure the connection is compatible, and I will show you what are compatible connections. Yes, sir? If they are an ANSI compliant manufacturer, it should be on their product as well, because ANSI specifies that it should say gate strength and then the amount on there. In this example, you're going to see an old, oops, when did that happen? You're going to see an old snap hook that is no longer used because it doesn't have a lock on it. It's been positioned on an eye-bolt anchor in such a way that a fall will produce a force on the gate. So this was sort of the first problem, and you can see it pop out here. So next, industry said, well, we're going to put a lock on the snap hook. This has a lock. And what you see here is a dynamic drop test hooked up to an energy-absorbing lanyard and a 220-pound weight. Now, as you're watching this, as soon as the weight falls, I want you to start counting to see how long that snap hook gate lasts for. Get ready. Here we go now. Not too long there. So we want to make sure that your connection is compatible. And one way we've worked around this is engineering the stronger gates in the snap hook. It helps us safety professionals and everybody to rest a little bit better at night. So here's some examples of what we call a compatible connection. The one on the left is compatible. The one on the right is what we call, or the middle, is a false connection where somebody hooks up into the back of their harness. They think they've got a connection, but they don't. And the one on the right, of course, is the forced rollout, where you have a gate, and it's such a, not a gate, a D-ring at such a size that it can put a force on the gate and cause it to burst open like we saw in the video clip. Here are some examples of incompatible connections that we can see, and the helicopter incident where there was the rescuers on the mountainside probably was B, where we have what we call a cross gate loading, and the force was on the weakest part of the connecting device, and it just blew it open. Here's a common practice that we don't like. It's called we call it girth hitching. We've designed some products that can be hooked up in such a manner. If you ever see this out in the field, what you'd want to do is look at the actual lanyard and see if there's instructions written on the lanyard that says you can do it. Good manufacturers will put those indications right on the lanyard so we know right away that is a legal connection. Of course, this one here is a snap hook to a snap hook. Totally illegal connection, could lead to rollout like we saw in the video clip. A lanyard's going to take the force of a drop of about 5,000 pounds and bring it to under 1,800 pounds that we would feel in our body. Many of the energy absorbers will take them down to 900. And the harness, of course, is going to put, it sounds like a lot of weight, doesn't it, or a lot of force. The harness is going to distribute that force into this part of our body and our shoulders, which deals very well with those amount of forces. Okay, I wanted to talk a little bit briefly about our anchorages. There's 3 classes of anchorages, and I think this is important because we have some more options now. This is from the ANSI Z359 family for fall protection. The 5,000-pound anchorage is an anchorage that our end users will look for fall arrest. 3,000 is what we can use for work positioning and rescue. And the 1,000 is, I think, actually probably one of the more interesting ones for you because that can be used for restraint. Now on a bridge it's not going to be too tough to find anchorage points that are going to hold this much weight. The difficulty is finding a way to connect to those anchorage points, and that's what we're going to look at here. We can see in the picture there's a beam strap right here. You've probably seen those before. Some of you may not have seen the picture in the far left, though, where we have a device where we can put up a beam strap and a rope grab up at height without even having to get off the ground. And here we can see some of the typical anchorage connectors, like the beam anchorage connector and the scaffold choker and the tie-off adapter. Some of the other ones that you may want to look at are going to be the concrete anchorage connectors, like we see right here, which can go right into the concrete. Of course, we'd have to be careful of pre-tensioned concrete. Here to the left, we've got the perimeter limiter, and this is a device that you could put on top of the structure that you're working on. It's mobile, and it will allow 2 people to work on it. And it also has a device for retrieval should a fall occur. Self-retracting lifelines. In construction, one of the ways I see these used very often is the picture that's in the upper left. And that's okay, but most people don't put an inline energy absorber onto that self-retracting lifeline. And fall over the edge will short circuit the energy absorber that's inside of the blue self-retracting lifeline here. So we need people to actually put an energy absorber on it. If you look at the indications of the SRLs, most manufacturers will say that an SRL cannot be used in this fashion. We actually make one that you can use over a leading edge and an attachment device that you can put on that SRL, so it can be used on the same surface as the worker. And this is where the rope grab comes in. Remember I mentioned that we can use rope grabs or we can use restraint systems. It's a very simple system. It's putting ourselves on a leash. You find an anchorage point that'll hold 1,000 pounds. You connect a rope grab to it, and a rope grab will slide along the rope to the distance you need. You set it, you lock it, you're in restraint, and you're in compliance. Very simple and easy. We're going to see a video clip here that's related to panic grip, and this is directly related to how we use our rope grabs. We're going to see a fall on a ladder here. Some of you may have seen this video clip before. Ladders put very vertical on the in front of a doorway. The user climbs up beyond the length of the extension ladder, misjudges his step, and takes a fall. But the part I wanted to focus in on here is what's in his hand. You can see he has the duster in there. Common thing people do when they fall is they grasp whatever is in their hand very tightly. And this could be important when we're talking about using these rope grabs. The one on the right is for climbing vertically, and if you hold it in the open position when you fall, it will still clutch onto the rope, versus the one in the left. If you hold that in the open position and you're using it vertically, you'll simply ride it all the way down. I've heard of now in just 3 years 2 different cases where people were using the equipment with their hand on it, and when they fell, and it caused the device to short circuit. And this was and it could happen on this. We sometimes see these on ladders. It's a vertical system. Okay, wanted to talk a little bit about horizontal lifelines here, and to do that, we wanted to quickly demonstrate the amount of force and the sag that can occur on a horizontal lifeline. And Gary and if Omar is around, let's see. Oh, okay. I'll just talk really loud. I think it's easier that way. Can you hear me okay back there? Yeah? No? No. I'm on a short lease here. Could you two please stand shoulder to shoulder? Okay. And they're going to support my weight. I'm just going to lean back into this, support my weight. Yeah, I'm kind of skinny, probably not too hard. Now we're going to put this in a horizontal configuration. Gary, would you stand over there and maybe choke up a little bit? Yeah. And, okay, so, ready? Get good and tight. Okay. The amount of force gets multiplied by many times. You as engineers know this, but let's take a look quickly at sag here. We're asking to hold that end. And now remember that the person falls in an overpass and impacts it. So hold on good and tight. I'm just going to slide this forward just a little bit, and you can see how much sag is there just sliding it this amount. We really got to take, I don't know if you could hear everything I was saying, but the forces obviously are going to be multiplied by a significant amount. And the second part that I wanted to demonstrate is there are energy absorbers on the horizontal lifelines that do permit them to sag. And just a little bit of tear out on those energy absorbers will produce a great amount of sag. I'm going to let's see. I'm going to pull up a quick video clip of an energy absorber on a horizontal lifeline. If you'll bear with me for a moment. Okay, and we're getting to it. Okay, could you hear the sound of that? That's the sound of an energy absorber ripping out. And if you look at the picture here, you can see the amount of how far that's gone down. And that's one of my concerns with pre-engineered horizontal lifeline systems that I believe are often used on some of our bridge structures out there. Some of the ones that you'll see are often these cable ones here. That's the one we saw in the video clip, but there are also some other ones that set up very quickly and easy, like the one on top and the one on the bottom. So unfortunately, I'm running out of time. We're going to move on to the next section where we're going to actually see some test drops with Matt Smith.